Hey everyone, it's Belinda. Welcome back to my channel. In this video, I'm going to show you how to create nested Revit families. As the name suggests, a nested Revit family is one that not only contains its own geometry, but contains other families as well. So what's the purpose of these nested families? Well, when you have a project with multiple rooms and you need to populate a set of equipment, or furniture, or walls, in each of those rooms, there are three ways you can do this. The first is by manually copying these pieces one at a time. And this is the most inefficient way of working because if you have a change in all these rooms, you're going to have to repeat the process several times. The second is by creating a group and then copying the group into all these rooms. This is a slightly more efficient way of working, but the problem is you'll have to make sure that all those rooms are identical. If not, and if the rooms vary slightly in width or length, you can't modify a particular group because it will modify every instance of that group. So we come to our third method, which is nested Revit families. I'm going to show you how that works. On the right, you see a snippet of a hospital project that I'm working on right now. There are 4 exam rooms that aren't identical. They vary in width or length or in the position of the sink in the rooms. So each of those exam rooms need to be populated with this set of equipment that you see on the left. This equipment consists of a patient lift above the bed, a stretcher, a bedside table, a cot on one side of the bed, and a doctor's stool on the other side of the bed. And then there are 3 pieces of equipment on the same side, which are a hamper or small table, 2 waste receptacles, and there's also an IV stand hiding back there. There it is. So all these pieces need to be copied into each of these rooms. I'm going to show you a hint of what the eventual outcome needs to look like. So here we go, 4 instances of these nested families in each of these rooms. You can see that the position of the cot or the waste receptacles is slightly different in each of them. So let's start creating this nested Revit family. I'm going to create a new family. Since each of those equipment pieces is a specialty equipment family, and I want to try to avoid any conflicts in the future, I'm going to create a generic model nested family and not a specialty equipment nested family. Next, I'm going to navigate to my folder and load in all the pieces of equipment that I need. The first thing I'm going to do is create an instance of the stretcher and align it to the y-axis. After this, I'm going to create an instance of the patient lift above the bed, and then the IV stand on one side and the doctor's stool on the other side. We also need a cot, two waste receptacles, another hamper, and we're done. We have our basic equipment layout. Now when I go to the 3D view, you can see that the patient bedside table needs to be rotated 180 degrees. So once I fix that, we're done. We have our basic static room layout. So this is not good enough. We might as well have just created a group in our project instead of creating another family. What we want to do is make this equipment movable so that it adapts to different sized rooms. I'm going to work on the cot on the right side first. And to make this cot movable, I'm going to create a reference plane, align the cot to the reference plane, and then lock the position. Next, I'm going to go to the Annotate tab and then create a dimension string from the center y-axis to the cot. I'm going to create a parameter from this dimension string, and I'm going to call this cot 120 width, just an arbitrary name. Now the important thing is to make this an instance parameter so that I can modify this dimension in each instance of the family, and I don't want it to be a type parameter because that would modify all the family types. So by creating this parameter, I'm able to control the position of the cart in the horizontal direction. Next, I need to repeat this process in order to control the position of the cart in the vertical direction. I'm going to create another reference plane, align the bottom of the cart to the reference plane, and lock it. This allows me to move the cart in the vertical direction. I'm going to repeat the process that I did earlier and create a dimension string from the x-axis to the new reference plane that we just made. I'm going to create a parameter from this dimension and call it cart 120 length. That's perfect. So when you go to your family types, you can see that these two parameters were added to the dimensions tab. Now we want to be able to move the equipment on the other side of the bed as well. I've tried this a few ways, and I've noticed that when you have multiple families you need to control, the best way to do is just to create a group from these families and then tie your reference planes to one of those pieces of equipment. Once I create a group, I'm going to repeat the same process by creating a reference plane, a dimension string to the y-axis, and then creating an instance parameter from that new third dimension string. I'm going to call this one hamper 16 width. And once again, I need to make sure that it's an instance parameter and not a type parameter. This allows me to move all those three pieces of equipment in the horizontal direction. I'm going to create yet another reference plane and lock it to that new plane in order to be able to move it in the vertical direction. This fourth parameter is going to be called hamper 16 length. We're done creating our four basic parameters. So once we save this family, we can then load it into our project and see what it looks like. So in my project browser, I'm going to scroll down to genetic models, find the family that I just created, and create an instance of that nested family. So because we created all those four parameters, you can see these triangular handles which allow us to move the cart in two directions, and then the waste receptacles and the hamper also in two directions. I'm going to copy this family over to the next exam room, and then I'm easily able to modify the position of the cart in order to fit this new room. I'm going to copy them over to the other two rooms as well, and using those handles, make them fit in those two rooms. So that worked perfectly. Now the main advantage from using nested families, apart from being able to move your pieces of equipment, is that if you make a modification to your main family, you're going to see that change in every instance of that family. For example, in my main family, I'm going to convert the stretcher into a patient chair. And you can see in the 3D view what it looks like right now. Once I load this new family back into the project and then overwrite the existing family, you can see that every instance was changed. Using these nested families really speeds up our work process, and it also makes sure that we're not going to miss out on any changes. One word of advice would be to keep your nested family as simple as possible. You don't want to over-constrain your model and then break those parameters. Hope you enjoyed this video. Stay tuned for my next one, where I'm going to show you how to create different types in your nested family by using a visibility parameter. Until then, I'm Belinda. This is Automation and Building Construction. Thanks for watching.